Okay, welcome to Algebra 2, Unit 3.3. This time we're going to look at the plus and minus, which causes reflecting, the A, which values can cause stretching or shrinking. Now, some confusion has occurred as to what we mean by stretch and shrink. I hope to help you with these notes here. Pause the video, copy down what I've got written here. Okay, now, if it is a plus and it's even, then it's going to be the U shape going up because that's a positive even. If it's positive odd, it's going to go up to the right, down on the left. The x-axis is what causes this negative. It doesn't cause it, but that negative actually flips over the x-axis, and we call it a reflect when it's got a negative in the front. That would cause the U shape to come down. Or on an odd function, it would cause this going up to go down, and this side going down to go up, because it's reflected over the x. On the A, here has been some confusion, and I thank you guys for telling me about this. But when that A value, just look at the absolute value, ignore the minuses. Some of the worksheets you work with, they really cause confusion to me because they include the minus in the A value. I think it's easier to separate these two. And just know if it's a negative, it reflects it. If it's a positive, it keeps it normal like the parent function. On the A, if the absolute value is between 0 and 1, then we call it a shrink because the distance from the graph, let's say it's an even graph, the parent function has a distance right here. If you have a fraction, that distance shrinks down. So it gets real wide like this, okay? So that's called shrinking when it's a fraction. Just think of a fraction as being a little kid. It shrinks down. It makes it a fat function graph. Okay? When absolute value of A is greater than 1, then it causes this distance on the parent graph that you have, like right here, this distance from here to here. When it's a number bigger than 1, it causes it to get real skinny here. And just think of it as being stretched right off the x-axis, right like this. That distance just stretched, okay? So now let's go to some graphs. So if we have the parent function, x to the fourth, and I see that we're going to shrink it, the first thing that I do is in my mind, I think of the parent function, and I think of the 3 points right near the vertex. The 0, 0, the negative 1, 1, and the 1, 1. And I kind of graph it, even if it's just in my mind's eye, but normally I sketch it on the graph. Now to go 1/4, I know this distance here is going to shrink. And here's how it happens. When I plug in 0, 0 times anything is 0. 1/4, what happens is when I plug in the negative 1, I get 1, but then 1 times 1/4 brings it right down here. So my graph just got a lot wider. Okay, now I might even go as far as to plug in the 2's and stuff, but I'm wanting to see that shrink. Now what'll happen if I reflect it? Well, it's the exact same points that I just got in the other graph, but now the reflection causes it to cross the x-axis, so it's looking like this. Sorry, I didn't draw it quite perfectly side to side, but you get the idea. Okay, it just reflects it upside down. Okay, next graph. If I'm looking at an odd graph, then I would think of the odd parent function, and I would plug in my vertex. Same kind of thing here. This time, when I get my value in my parent function, I take that value and multiply it by 2. And so at negative 1, instead of only coming down to negative 1, I go negative 1 down to negative 2. And positive 1 up to positive 2. So you can see the stretch is occurring right there. And it'll occur for every point. Now, if there's a reflection of that, then again, whew, that was close. Again, instead of having the negative 2 here, And negative 1 times negative 2 would be positive 2, so I come over to negative 1 and go up to positive 2. Come over to positive 1 and go down to negative 2. So I would have this kind of a reflection. Okay? Now, on this graph, here is my parent function, x to the fourth. Again, even when I see all these different things, I still go to my parent function and I graph it in my mind's eye, and usually I sketch it on the graph just to have it in my mind's eye and make sure I'm not making any errors. Then the next thing I do is I go to the vertex. My vertex, remember, that's a positive 2 because the negative's in the formula, so it's positive 2, negative 4. Now I have some students all the time that will try to switch both of these or switch this one. Don't do that. Remember, the negative is in the formula here. That's why that's a positive 2. So this tells us to go 2 to the right and down 4. And that point is this point. That 0, 0 has just become 2, negative 4. Okay, so now when I go 1 to the right of, or yeah, one to the left, so sorry, 1 to the left, normally I go up 1. Instead, when I go 1 to the left, I'm going to go up 3. So I go 1 to the left, and I go up 3. Now, when I go 1 to the right, I normally go up 1. Instead, I'll go 1 to the right, up 3. Now, this is not like the square. It still needs to have this little bit wider base, but you've got to accommodate that stretch. Okay? That can be a little bit rough to do. Don't worry too much about it. Just get it through the 3 points and make it clear to me that it's an even, that it's got that U shape. Don't make it into a V. Okay. Write in the equation given a graph. These are really, really fun to do because you've got the skills now. So the first thing that I do, again, is I go vertex. Okay? I think of my parent function. I usually dash it on the same graph. And then I think in my parent function, it was 0, 0, 1, 1. I even sometimes will go negative 1, 1, just to, negative 1, hello. Just to remember these were the 3 points around my vertex. Okay? Well, my vertex on this new graph happens to be right there. So I write out my vertex. I know that that's at negative 2, positive 3. I will even go to my answer and switch my H and my K. This is a negative 2, which makes that a plus, and positive 3. Okay? Now, all that I need to work on is my A value. Well, do you notice how you go over 1, up 1? If I look here, I go over 1, down 2. So what's so awesome is I can see it in my T-chart over here. If I just focus on my over 1, up 1 right there in my parent function, and I plot those first 2 points in my new function, I've got my vertex here. That was my vertex. My parent function, this is my vertex in my new function. And now my next point happens to be at negative 1, 1, and I look at the distance there. In the parent function, it's 1, but here, 3 minus 1 is, actually I shouldn't say 3 minus 1. 3 minus what is 1? It would be a negative 2, and that's my A value. I get negative 2. Because of the distance I have to travel to get from my vertex to my next point is negative 2. That tells me my A value is negative 2. Now, I might check, does it look like a negative graph? Oh yeah, it is going up to the left and down on the right. Whew, I did it. That's the hardest one out of the whole unit. At least this unit. Have a good one.